Okay, so today's lesson is about quadratic word problems. So there's different types of word problems that we're going to cover. One of them is number theory, and another type is projectile motion. This video will only focus on the number theory type of problems. So before we get into the problem, some key words you need to know. Consecutive integers. So these are two integers that come one after the other, like the numbers 1 and 2, 4 and 5, and so on. Without using specific numbers, we usually say two numbers are consecutive integers. They follow the form n and n plus 1. If I say an integer is even, an even integer is usually written in the form 2 times some number n. And you could prove that 2 times any number will give you an even number back. To have an odd integer, you do 2 times n plus 1. N is any integer. Okay, and that is very easy to see. If I do 2 times 2, which is 4, add 1 gives me an odd integer. So those are some of the basics, and from there we can look at consecutive odd integers and consecutive even integers. So when we say two integers are odd and consecutive, those are like numbers 3 and 5, or 7 and 9. So they come one right after the other in terms of the odd numbers. And to write it, we usually start off with an odd integer, which we know is 2n plus 1. To go to the next one, you usually add 2, because the difference between 5 and 3 is 2. Between 9 and 7 is 2. So I'm going to basically add 2 to this previous one, which gives me 2n plus 3. So we would say that 2n plus 1 and 2n plus 3 are consecutive odd integers. And you can choose any number for n, substitute it in, and it will work. To do consecutive even integers, it's very similar. We start off with an even number, 2n. To go to the next one, you would have to add 2. But get numbers like 2 and 4, 6 and 8. Same concept. So if I start off with 2n, if I add 2 to it, I'll get 2n plus 2, which is another consecutive even integer. We're going to use these definitions to solve word problems that are basically focusing on number properties. So I have a couple examples that we'll go over, and then there's a worksheet that will be posted onto Google Classroom for you to work on. So the first example we're going to cover, find two consecutive odd positive integers whose product is 195. So one of the things we need to look at is the key words in this one sentence or word problem. So I'm going to underline the keywords in yellow. So we have consecutive, odd, and positive. So these are going to tell us with our answers what kind of numbers we should be getting as the final one. So we want to keep that in mind. Another keyword, which I'll underline in green, is product. So we need to know the words like product, sum, quotient, and difference to help us construct this equation. So the word product means multiply. The word is means equals. So what we're going to have in our equation, I'm going to have something equals 195. So I need two things multiplied together, and those are my two consecutive odd integers. So we know what consecutive odd integers are from the previous slide. You can see consecutive odd is this. So what we're going to do is use that to basically make an equation. I'm going to take those two and multiply them together. So we're going to have 2n plus 1 times 2n plus 3, and that equals 195. To solve this, you're going to multiply or distribute on the left-hand side, and then eventually you're going to want to solve the quadratic equation. You can use any method to solve it once you get to that point, whether it's factoring, completing the square, or quadratic formula. Choose a method that works best for you. So let's multiply the two binomials together. We'll get 4n squared (6n), 2n, and then 3. Okay, so then if you combine like terms, we'll get 4n squared plus 6n, not plus 6n, plus 8n plus 3 equals 195. And then we're going to want to solve it, so we need to get an equals 0 where the 195 is. So if we subtract 195 from both sides, we'll get 4n squared plus 8n plus, not 3, minus 192 equals 0. And now you could decide, do I want to use factoring, quadratic formula, complete square, whatever. I'm going to do factoring because with this problem, factoring actually makes it a little bit easier. If you don't know that this factors, you could always do quadratic formula. Quadratic formula is basically a fail-safe. It works in every case. So what I'm going to do here is I'm going to divide everything by 4. Okay, basically take out the GCF. So when I divide everything by 4, I'm going to erase the slide. So let me just write the previous equation. And we divide everything by 4. So we get n squared plus 2n minus 48 equals 0. Now, if you didn't realize that this factors, you could do quadratic formula straight from here as well, and this would be easier if you do it from here with the quadratic formula because the numbers are smaller. I'm going to factor because this is an easy one to factor. Two numbers that multiply give me negative 48, but when you add them, give you positive 2. So we'll have n plus 8 and n minus 6. And you'll set each of those binomials equal to 0 and solve for n. So we'll get n equals negative 8 and n equals 6. Now, going back to our problem, consecutive, odd, positive integers. So we want positive answers. Negative 8 will not give us a positive answer. So we could actually cross that out. Now 6 is not odd, but n is not the actual number. We have to plug it in to get the answer. So 2n plus 1, if we plug in 6, get 2 times 6 plus 1, which is 13. So there's one number, and we're going to do the same thing. 2n plus 3, that was our second one. I'm going to plug in 6. 2 times 6 plus 3 gives me 15. So those are my two answers. To check it, if I do 13 times 15, it should give me 195, which it actually does. Okay, so that's the first example, which is one of the easier type. The harder one is on the next slide, where writing the equation is a little more involved. So we're looking for the integers where the product of two consecutive integers is 3 less than 3 times their sum. So, again, keywords. Consecutive integers. And the rest of it is going to be stuff we're going to need for our equation. So I'm going to need 3 less than 3 times their sum. That's going to help us when we write the equation, as well as the word product. So if we go back to the beginning part, consecutive integers. These are my consecutive integers. N and n plus 1. So I'm going to multiply those two together. So we're going to do n times n plus 1, and that takes care of the first half. Everything after the word is this second part, and we're going to write it 3 less than 3 times their sum. So the way we're going to write it is we're going to read it from left to right, but we're going to write it from right to left. So when it says 3 less than, this part means minus 3. The 3 times their sum, I'm going to take the two numbers and add them, multiply by 3. So we're going to do 3 times their sum, so it's n times n plus 1. And then I'm going to put at the bottom, or at the end of it, a minus 3. So this is saying 3 less than 3 times their sum. Same as the previous one, you're going to multiply, distribute, combine like terms, everything you need to, solve the quadratic. So on the right side, we'll get n squared plus n equals this inside part is 2n plus 1. So if we distribute, we get 6n plus 3 minus 3. And on the right side of the 3's, when you combine them, they'll give you 0. So I'm going to subtract 6n from both sides. So we'll get n squared minus 5n equals 0. And then we can take out a GCF. And then when we set everything equal to 0, each part, we get n equals 0, and minus 5 equals 0, so then n equals 5. Okay, now this one could have potentially 2 answers, because there's 2 sets of consecutive integers. One where n is 0, one where n is 5. So we will have 2 cases. So when n is 0, what's the next consecutive integer that'll satisfy this? So we're going to do n plus 1. If I plug in 0 for that, that gives me 1. So one solution is 0 and 1. Now we're going to look at when n is 5. Well, if n is 5, when we plug n into n plus 1, that will give me 6. So another solution is 5 and 6. And both of these would be considered correct. If you were to check them by substituting them back into our original equation we made, they both are valid. Okay, so this is how to do the number theory type of word problems. Next time I see you in class, we will cover projectile motion, which is the act of throwing an object in a parabolic path. So this video, which is about 13 minutes long, I know it's lengthy, but it at least has 2 good quality examples to help you through the worksheet. So on Google Classroom, you will have the worksheet posted, follow the directions, and complete it.